about some of these things already. So, relational operators. We already have the idea of if A is greater than B, if B is less than X, and that kind of thing. The only thing to remember is what is the opposite of? You know, if you do if X is greater than Y, the opposite of that is not if X is less than Y. It's not even if Y is less than X or greater than X. What do you have to do in order to do the opposite without using the not operator? You make it greater than or equal to. That is the opposite. Because otherwise, if X equaled Y, then that would be false there. But if we had worded it like this, the behavior on if X is actually equal to Y. Okay, I may be spacing out here.
Me too.
Anyways, if you want to cover all of the conditions that this one doesn't cover right here, because you could phrase that like this: if something A, else B, and then you wanted to word it the opposite so that B came first, like this. Then you would have to make it less than or equal to. Exactly, exactly. So that you don't get messed up by the case where X equals Y. In this case, if X is equal to Y, you wanted it to trigger B. So if you were going to rewrite it, you'd want it to trigger that, and it wouldn't if we had left that off. So the symbols less than, greater than, equal to, less than or equal to, greater than or equal to, and then lastly not equal to. Their opposites are pretty easy. That's the opposite of that one. That's the opposite of that one. Not equal to is the opposite of that one. You know, what's the opposite of that one? Less than or equal to?
Less than?
Well, greater than.
Oh, greater.
Yeah, yeah, yeah.
I was looking at the second one. Less than.
I knew you knew it, but there we go. Like that. You can also always opposite somebody just by prefixing the entire expression with a not. So here's the logical operator, the comparison operator, and their little opposites. And what do I mean by that? If your logic is this, if X is greater than Y, but you want to retool it so that B is up at the top, just like we did there, we could have done this. If not, wait, I've done that one wrong. Steal that in if not X is greater than Y. That would handle it just the same way.
So if you put the exclamation point on the outside, wouldn't it just make the, or does it matter where you put it, I guess?
Well, it does matter. Remember in C, you have to put the entire logical expression within the parentheses, unlike some languages. If you wanted to, you could do that. The only time you'd really have to take care is if X was a Boolean variable rather than a number, but you wouldn't be using greater than to compare Boolean anyways. So that's how I would express it. But if it was a more complex expression than just X greater than Y, yeah, I would coordinate off with that. But in general, by the time you start writing logical statements that have nots in them, then people's brains start to freeze up trying to figure out what it does. And if you can rewrite your expression to not include a not, it's better. So of these two, rather than that one, I think that this one is better than that. They mean the exact same thing. It's just easier for our brain to go, oh yeah, I know what's going on. If X is less than or equal to Y, I'm going to do that. Rather than if not X, what? Yeah, yeah. If you wind up with an expression with more than one not in it, then really figure out how to rewrite it. Missing, oh well. A Boolean expression evaluates to true or false. And so you can store its result in a variable. 12 greater than 5, that returns a true. So if you wanted to, you could store that in a variable. A equals 12 greater than 5. Just like that. Result is equal to x less than or equal to y. Typically you call that a flag. The if statement. We know what an if statement is. We're not going to spend a lot of time on this. If it is raining, take an umbrella. If it is cold outside, wear a coat. Otherwise, wear shorts. You know, that kind of thing. Or if the condition is true, do something. If it's just an if rather than an if-else, then there's nothing on the other side, you know. Not that this is a flowcharting class. You can chain up a whole bunch of sequences, statements. If you only have one statement, you don't need the curly braces. If you have more than one statement as the body of the if, you have to have curly braces delineating the entire block. The same is true of while loops. If you have while cold outside, then if it's only one statement like that, is while cold outside, wear a coat. You don't need to put curly braces. On the other hand, I would recommend you always do it unless you have a good reason not to, and I can't think of a reason not to. The only reason I skip putting curly braces when it's a single statement is just so I can fit more code on the screen when I'm showing it to y'all. And when you're writing your own code, you don't really care about fitting as much code on the screen. If expression statement. Okay, like I said, we're going to go through this one pretty fast. We already have been using all of this stuff. We don't need an example of an if statement because we're awesome. If average greater than 95, display congratulations, that's a high score. Here's the one thing that people usually do wrong with if statements, while statements, everything in this language that relies on that kind of block. If you write this, if score is greater than 90 or greater than or equal to 90, print A, because you made an A. But you put a semicolon there. Well, we put a semicolon everywhere else. What that means is it's as if you had written this code. This code right here is the same as there you go. That's exactly what it does. And so this happens no matter what. So by putting a semicolon there, you're short-circuiting it.
Oh, so that why kind of like how do statements, they kind of skip over what's in, well, because, you know, do statements have the condition at the bottom instead of...
Right, they put the condition at the bottom, and then they actually do put the semicolon at the end of it. That's the only time in this kind of stuff that you put the semicolon. In general, anytime you put a semicolon in front of an opening brace, it's going to mess things up. Like if you define a function. Hopefully y'all watched the video on functions. If you're defining a function like that, if you put a semicolon there, that's going to break it. If you do this, while temperature is less than 0 degrees, you know, turn up heat, whatever. If you put a semicolon there, that is the same thing as writing it like this. While temp is less than 0, do nothing. And then turn up the heat. You know, like that. So, never put a semicolon at the end of an if, never put a semicolon at the end of a while. Just breaks it. Alright, I'm going to delete these bad examples. Except to say, don't put the semicolon there. And same comment on the if. Because this would be an infinite loop. You'd run it and you'd wonder why the program was just sitting there. And if this is a larger class, 12 or 20 people or whatever, then definitely when I was wandering around helping people, I'd be pointing to semicolons and tell them to take it off. Yeah. Expanding the if statement Need more than one statement? Put the curly braces. If you only have one statement, the curly braces are optional. I recommend going ahead and doing them anyways. The reason why is it just kind of makes it easier to come and slip in an extra line of code there without having to change anything. If else, two possible paths of execution. If this expression is true, do one block. Else, do another block. If you're hungry, eat some food. Else, don't. If you're got money, go out to eat. Else, stay home. That kind of thing. And again, you can use the curly braces if you need to. You use curly braces if the block consists of more than one line of code. Checking to see if a number is even or not. Modulus. If number modulus 2 is equal to 0, well, if it's true, if it really was equal to 0, that meant that it divided evenly. There is no remainder, so you print that it's even. Else you print that it's odd. Testing the divisor. This program asks for the user for two numbers, num1 and num2. Num1 is divided by num2. The result is displayed. Before the division operator, however, num2 is tested for the value of 0. If it contains 0, the division does not take place. Why? Because if you divide by 0, it would crash. So, enter a number, read it into num1. Enter another number, read into num2. If num2 is equal to 0, that would be bad, so we're going to print an error. Else, go ahead and do the division. Nested if statements. You can put if statements inside of if statements. Like this. If money is greater than 0, then if hunger is greater than 0, and if food and house is equal to 0, we don't have any food. Yeah, see out. Better go out for food. So we just nested some ifs. If money wasn't greater than 0, it wouldn't go in here. If money was greater than 0 but we weren't hungry, wouldn't do anything. All three of these conditions have to be true before it executes that one. Now this is somewhat silly because we could chain these together with ands. If money is greater than 0, and hunger is greater than 0, and food and house is equal to 0, better go out for food. So sometimes you'll nest things in order to accomplish your logic, and sometimes you'll use and statements. And it'll probably be pretty clear to you what you want to use. So are you employed? Yes or no? If you're not employed, you're going to say you must be employed to qualify. Inside this if statement is going to be another one. Are you a recent grad? Yes or no? If you're a recent grad and you're employed, then we're going to print you qualify for the special interest rate. Otherwise, we're going to display you must have graduated from college in the past 2 years to qualify. This is making it look like there's three possible states to this. You can be employed and be a recent grad. You can be employed and not be a recent grad. But they don't care about if you're a recent grad if you're not employed. So they're missing the fourth state there. No biggie. They're just snobs like that. You better be employed or else you don't get to talk to them at all. So let's code that up in a couple of different ways. So new project. We know we're going to need our boilerplate. Or not. Why does it never find my boilerplate? Okay, fine. Typing it in every time certainly burns it into your brain. So add a new item. I think I'm just going to call this Chapter 4. We're going to be done with Chapter 4 by today, I would believe. So I know I'm going to want strings, and I know I want IOStream. So # include IOStream. Everybody watch the one on header files?
Yeah.
Watch the videos. Okay. The other one is include string.
It was just weird to me because, like, I mean, yeah, make sure main file source code, like, a lot less, because all of it's in the header file, but then you still have to include that header file, so, I don't know. I just don't really see the point of
C++ is a little bit, well, later languages made it not quite as necessary. Or, well, in Java, there's no such thing as a header file. And you don't have to define the functions in any particular order. But in C++, the functions must be pre-declared before the compiler will recognize what they are, and that's what the header file does. Okay, so here we go. Int main. I forgot my using namespace.
I'm just going to point this out. We learn about header files at eCentral. That's like one of the first things that you just,
Yeah.
because we learn C programming.
Yeah. Okay, good old boilerplate. Let's ask them if they're employed. Let's ask them if they are a recent grad. So cout, well, we're going to need two variables. Both of them, let's make them strings. String employee, EMP, and string grad. So let's ask them, are you a recent grad?
You want to do, are you employed first? I asked for the state of code sake.
Yeah, it doesn't matter really, according to our logic. If we were going to kick them out and not even ask the other piece of information, then yeah, we would care a lot about which order. Okay, so are you a recent grad? And then we're going to read that in. I forgot to tell them to type in either a Y or N.
Is there like an ignore case for?
You can convert strings to uppercase,
Yeah.
but there's no dot equals ignore case like there is in Java. Okay, cout, are you employed? Y or N. Cn into EMP. Okay, they showed 3 states, and they did that with nested loops. So we may as well implement it their way first. If employee is EMP is equal to Y, if grad is equal to Y, cout, you qualify for the discount. And then they stuck an else here, and they stuck an else here. So, else, you see, I think you could just get away with doing this with an and rather than nested ifs. You don't need to tell them why they didn't qualify. Or if they do, you could just print out the message, you must be a recent grad and employee. you know. But instead, we're going to give them too much information in this clumsy way. So, else, cout, sorry, you're not a grad. That's that first else. And then down here, else, cout, sorry, must be employed. And to make this all fit on the screen, I'm going to do the alternate way of putting the braces. No, I'm going to leave it alone. It is taking up the entire page. But if we moved, you know, the opening braces up into the one line above, then it would fit more easily on the page. But it's all right. Okay, neat. Getting an error message.
Don't forget your system calls.
Chapter 4.py. Rename. Chapter 4.cpp. Sorry, we're not writing Python code. If you typed .py because I said it, fix that to .cpp by clicking on the file name in the Solution Explorer and doing rename. I'm probably going to wind up rebuilding the whole thing. All right. Am I a recent grad? Yes, I sure am. Am I employed? No. Sorry, you must be employed. So I don't know if y'all got what I meant by there being actually 4 choices, but we have 2 variables here. We have employed, we have grad. And each one of those has 2 states, y or in. So you have a combo, 4 choices there. But they're only telling us information. If you're not employed, that's just it. You get a big message there. So, sorry, must be employed. Then why did they even ask us if we were a grad, if that was the case, you know? So by using the nested if, they broke it down so that if you were employed, they zeroed in a little bit more carefully on their choices. Here's how I would write it. I would assume that they're smart enough that if we tell them why, they can pick the reason. So I'm going to scroll down here and change this logic a little bit. If grad is equal to y and employee is equal to y, then tell them they qualify. Cout. You qualify.
Yeah, that would have saved us a lot.
Else, tell them why they didn't. Cout. You must be a grad and employed. There you go. So nested ifs and stuff like that are absolutely great. but if you can express something just with an and statement instead, simplify the logic, then that's what I recommend doing. Any questions over that concept? Are we all good, or anybody need typo correction?
Is just looking at it in C++, is it the same how it is in Java for or to
Right, right. So
I was just making sure.
So ampersand means and in some languages you actually spell the word and out. In this one you don't. If you're a Python maniac and you really wish you could use the word and there, then you could come and use a pound define.
Yeah.
Pound define the word and to mean two ampersands. Don't do that. Just get used to the language. Okay.
Why did it make and purple? Just type it. Okay.
Pound define and there's two of those bad boys. Pound define true as a 1. Good question. It's treating and like it's a keyword. No. Okay, so all of the pound defines are being turned color-coded purple. Okay. So if you have and, it means that both sides must be true before it will happen. So you can create a truth table. You have condition X and you have condition Y. And they are connected by an and. I'm going to use 1 and 0 for true and false. So if you have two things that are false, the answer is false. Because they both need to be true. If you have one thing that's false and one thing that's true, if you're not employed but you are a grad, you still don't get it. If you're employed but you're not a grad, you still don't get the discount. Both of those must be true because of the and statement. So that's a truth table. Doesn't have cute little lines making it a grid, but recognize that as a truth table. So X, Y, result. You know? Also, there's or. So if you write if X and Y, it means both must be true, or the if statement won't happen.
Fix the and. Right?
Yeah. Well, I'm going to leave it like that, but okay. Just know that ampersands. Both. Okay, I'll do it.
Oh, I thought you had said or, so that's what made me think you meant to put
Oh, got it.
or. So
Yeah. So both must be true for it to enter before this condition will be accepted as being true. So and is those symbols, or are expressed by two vertical bars, which is a shift of the backslash, the backslash being the one above the enter key. So you write something like this: if A or B, that means if one or the other or both are true. At least one of them must be true. At least one of A or B must be true. That's the difference between and or. So if we make a truth table for for or, it looks like this. X or Y. Let's go ahead and X, Y, result. Fill in our numbers 0, 0, 0, 1, 1, 0, 1, 1. If they're both false, it's still false. This is more like if you're sick or you're tired, are you going to stay home? If you're not sick, you're not tired, you're not going to stay home. If you're not sick but you are tired, must be a cushy job, we're going to stay home. If we're sick, but we're not tired, we're going to stay home. If we're both sick and tired, we're going to stay home, maybe for 2 days. There we go. So that's the truth table for an or. That's up there was the truth table for an and I'm going to cut that and move it just where it's here. So say we want to use, let's make a variable called T, which stands for temperature, or TF for temperature in Fahrenheit. And we want to print a message of whether it's water is going to be a solid, a liquid, or a gas. So if the temperature is less than 32, or the temperature is greater than 212, we're going to write out not a liquid. Excuse me, TF. If the temperature in Fahrenheit is less than 32, or the temperature in Fahrenheit is greater than 212, see out not a liquid. If you wanted to do the opposite and you wanted to say when it was a liquid, you wouldn't use an or, you'd use an and. You're going to say if the temperature is greater than 32, or greater than and equal to, if you want to exactly flip the logic, and the temperature is less than or equal to 212. So if temperature is greater than or equal to 32 and temperature TF is less than or equal to 212, see out it's a liquid. So if you're going to check to see if something is within a range, you probably use an and. If you're going to check to see if something is outside of a range, if it's below freezing or above boiling, you'll probably use or. Use and if checking to see if something is within a range. Use or if checking to see if something is outside of a range. If, else, if. You can chain if statements, many of them in a row as you need to. You know, if grade is greater than or equal to 90, print A. Else, I almost slipped into Python. Else if grade is greater than or equal to 80, see out B. Else if grade is greater than or equal to 70, see out C. So on. Whenever you have a series of else ifs, throw on one final else just to handle the case if none of them are true. In this case, if they didn't make an A, B, or C, they are depressed because we're going to give them an F. We're mean. Okay, there we go. Like that.
But I'm guessing isn't the bad thing about if you use like a bunch of if statements instead of else if? Say if your grade was like a 91, it would print out A and B because it's greater than 80. Well, it's greater than all of them, so it would print all of them out if you just did a chain of if statements, right?
Right. If you didn't do else, then the code's not going to work right. It's going to look good, but it's not going to work right. And in fact, this is one of your exam questions, so you may as well burn it into your brain right now. What is wrong with this code? So here we go. If grade is greater than 90, print A. If grade is greater than 80, print B. If grade is greater than 70, print C, else print F. Looks good. There's always like, you know, a quarter of the class that says that's good code, even though I've warned them that this is a question. What is wrong with it? If you type 90, then it's going to print out that you made an A and a B and a C. So that's why you use else's. It makes it mutually exclusive. Only one of these four things is going to happen.
Small question.
Yeah.
Where's the D grade on this?
This is a rigorous, mean class. You have to make a C to pass. Okay, if you were going to modify this to throw D in, we'd just tack that on right here. Else if grade is greater than or equal to 60. C out D. Like that.
No 60s or Fs in this class.
Nah, they're not. But nobody's going to make a 60. I want y'all all to ace the course.
I've already got it.
I've just gotten to the habit of anything being below a C is an F. That's how I was raised.
Yeah. You made less than a 90. Okay.
You dishonored your family.
That right. You've dishonored your ancestors. Okay. So that's what you use else ifs for. Some languages compact them to just be elif. I believe Visual Basic has some weird thing like that too. I know Python does. Okay, if you wanted to fix this code so it would work here, if you didn't want to use else's, excluding the fact that this was going to mess you up, say you got really frustrated with that and you deleted it, how could you rewrite this so that it would actually give you the right answer without using else's?
Well-
Make it as if it's in a nested if statement.
Without any nesting whatsoever, we can do it.
You're asking how you would get the correct answer, but
Right.
without. Well, you could just change those to else ifs, and then.
Yeah,
it would
you could
still-
use else's, but how would you do it without else's?
Okay.
You would do this. If grade is greater than 90, excuse me, if grade is less than 90 and grade is greater than or equal to 80.
Oh, well, yeah.
You're just establishing a range like that. And that works. And whenever I ask people to write a grade program, some people go ahead and do that and they define the whole range and it looks good to them. That's great and all, but you don't really need to do that because what if the prof decides, okay, let's go ahead and continue this little thought experiment. So if grade is less than 80 and the grade is greater than or equal to 70. And yeah, you could have used nested ifs, but I shudder to think of what it might have wound up looking like. So anyways, problem is what if the professor decides that, you know, anything above an 85 is a break for an A or a B. You have two places to change it. You have to change it there and there. And they decide that a 70 is a break between a B and a C. Yeah. So you just have more stuff. The expressions are harder to read. It's a slightly more fraught with error if somebody's going to go in and make a change to it. I'm going to undo those changes and then put that this is the wrong way to do it and why. Without the else statements, multiple grades might be printed, are likely to be printed. If you score an 81, it's going to print what? It's going to print B, C, and D, but it's not going to print F. In fact, the if, I think, is the only logic that actually is correct at this point. No, it would work for anything less than 70. Because if you type 69, you're going to get a D. If you type in 59, you're going to get an F. But everything above that is munged. Okay. Here they've gotten clever and defined the breaking points of the scores as variables so that the table could be adjusted. So you could make it so that 80s and above are A's and 70s are, are B's and 60s are D's or whatever. And you could do that either with pound defines or you could just define these as constants. Flags. A flag is a Boolean variable. Can also be defined as an integer. Typically, it's a variable that signals a condition. If drive out of space. If too cold to go outside. If user wants to exit. That kind of thing. Apparently we don't talk a lot about flags.
I was saying, I ain't even giving it a whole slide.
Yeah. Okay, here's an example of a flag. Okay. Boolean quit now is equal to false. If quit now is equal to false, do some stuff. Then ask the user, do you wish to quit? 1 for yes, 2 for no. This is actually supposed to be a while. I goofed. While quit now is equal to false. Keep repeating this stuff. Do a whole bunch of stuff, then ask them if they wish to quit. Read that in. See in it's some input, and if that input is equal to 1 because they wish to quit, then you set quit now equal to true.
Yes, but even without having the quit now, it makes it easier to read, but you could still do it without doing that, using the same amount of lines of code, right? If you just wanted to break, like say if.
I would use a break statement. We haven't talked about loops enough for me to throw break statements in, but you could write this in a way that it was a lot cleaner. But I was just trying to demonstrate a flag. A flag would be any reason for this thing to exit. Yeah. Something else, you might have a global variable called error, and you set error equal to false. And if something anywhere ever sets error equal to true, then it would exit the loop. That kind of thing. That's bad programming, but people do that. I've done it. Okay.
What makes it bad programming?
Global variables in general are bad programming. So use the logical operators and, or, and not. And both expressions have to be true for the result to be true. Or if either side is true, it will be considered true. And if you're wondering, where's the exclusive OR because you've been exposed to electrical engineering, there's a bitwise operator that does exclusive OR. The idea behind exclusive OR is if one side is set or if the other side is set, but they're not both set, that's the only time. But there's no logical operator like that expresses that. And then not reverses the truthiness of the expression. If we wanted to do this, you see where I wrote while quit now is equal to false, we could rewrite that with a not. While not quit now, like that. So anytime you find yourself writing while something equals false, you could rewrite it to say while not that variable name. And we did show an example of that earlier. If you wanted to do it while t is less than 32, less than or equal to 32, you could rewrite that to say if not t greater than 32. If that makes sense to you, more power to you. Like I said, I usually rewrite these expressions to avoid not, unless it's something as simple as that. Even if that were true, I would rather change this variable from a negative, quit now, is equal to false, to a positive. I would write this as keep running is equal to true, and then while keep running. And then if anything ever set quit running, keep running to false, then you bail out of it. Just because I think things without nots in them are easier to read. Alrighty, so here's our variables. X is 12, Y is 5, and Z is -4. This expression here, is that a true or a false?
X and Y, so that's 12. 12 is greater than 5, so yes.
That's true.
And Y.
Yeah, so X is greater than Y. Is Y greater than Z?
Yep.
Indeed it is. So both sides of the AND are true, so the result is true. How about this one? X is greater than Y? It sure is. Is Z greater than Y? No. So since it was an AND, both of them had to be true. Since both are not true, it's false. How about this one? X is less than or equal to Z?
False.
That's false. Is Y equal to Z?
No.
No. So doesn't matter. It's false. X is less than or equal to Z? That's false. Is Y not equal to Z?
That's true, but the first one was true.
That's true. And since it's an OR, only one of them have to be true. So that one's true. And then lastly, X is less than or equal to Z? Greater than or equal to Z?
It is greater, but it's not.
But it's got a not in front of it. Right. So I'm going to make up some of these of my own for y'all. A is equal to 3, B is equal to 4, and C is equal to 5.
The ones on Code Academy, Code Academy, they do it to where like they combine those operators, and it really makes you think like they'll do that. Because I guess they take like some take precedence over. I think like the and takes precedence over the or if you do it all together in one statement or something like that.
Yeah. I'll upload this for y'all so you don't have to type it all in again. I guess I didn't, yeah, all right.
Is there a reason the PowerPoint doesn't talk about that?
I don't know. I can't think of one. And then lastly, not. A is less than B, and not A is greater than B. Okay. Let's upload that, let y'all fill it out and resubmit it as part of a daily assignment. Really, I should not have put these three statements in their own. All right, guys, refresh your Dropbox. You'll see a Dropbox E with a document in it. I do want you to go ahead and fill this out. I'll give y'all, a little bit of time to do it, and then we'll do it together afterwards. So open it up, and all you need to do is if A is 3, B is 4, and C is 5, tell me whether this expression is true or false. Let's do the first one together. Is A less than B? A is less than B, so it really doesn't matter about that. We know that since it's an OR and one side of them was true, then that one's a true.
Say, I don't know if this will work, but say if you put, even though there is an OR, if you put the other side of it in parentheses, would it take precedence or would it just still run the same?
In this case, parentheses,
Doesn't matter.
right. I can't think of a way to force the B greater than C to be evaluated first, and it wouldn't matter if it was. Actually, that's a very interesting point, and I'm not going to be able to tell you the answer unless we went to some effort. I just wouldn't bother.
I agree. Because there would be no ever a point for you to need to do that.
Right.
Well, it won't let me on this one, so I'm gonna try to
Okay,
go
if you
back up.
can't edit it,
Yeah.
go up to View and see if there's an edit option. Edit document.
Oh, there.
Yeah. Sorry about that. So you got yours. Okay.
And it's hard.
Yeah. And does have a higher precedence than or. So, if we worded this one without the parentheses, it would work. Why do I say that? Because and has a higher precedence, that will get done first. But I don't see much need for relying on somebody to know that. I'd rather break it apart like that. And if you meant it to look like this, if A is greater than B or A is equal to 0, and then you wanted that to be one clause, and then you wanted this to be another clause, you absolutely would have to express it like that. You'd have to have the parentheses there for that to work. Okay, we're going to veer outside of programming just for a second and go into logic, which is things are expressed like this. Ands are expressed by multiplication. That's not true. I believe that is true. And ORs are expressed by addition. So if you wanted to write if A or B, if you're writing this in logic, you would do A plus B. If you wanted to write if A or B and C or D, then you might do this. A plus B, C plus D. I really hope I have those right. We could figure that out real fast by going back up to, if you have this little table here, even without having the operators, so A, B, and R, where R is the result. Is this an AND truth table or an OR truth table?
It looks like an and truth table.
It's an AND truth table because there's only one case that's true, and that's that. What if you thought about it as being A times B? 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. So, and then when they're expressing the logic, they leave the asterisks out. So if you want to say if C and D, then that is just expressed as CD like that. All right. Don't much care about that. This isn't a discrete math class or a logic class. Just wanted y'all to see that. I am now going to purge that from our memory. So here's a comment. Use parentheses to make clear which is done first in a complex logical expression. By the time your logical expression has like more than 2 logical operators, if it's got 3 or 4 or 5 or 6, you probably ought to break the logic down into some other way of doing it, because it becomes almost impossible for your brain to eyeball that and go, yeah, I understand what it's doing and it's correct. So not has a higher precedence than anything else, followed by ands, and then followed by ors. If the expression can be determined just by evaluating the left side, then the sub-expression will not be evaluated. The one on the right side. That's called short-circuiting. And I'll show you what I mean. Say temperature, or T is equal to 32. Let's use X and Y. X is equal to 3, and Y is equal to 4. So if you write this, if X equals 3, or Y is equal to 3, and then later on you write if X is equal to 3, and Y is equal to 3. Okay, so this is an OR, which means that we check the first one. Is X equal to 3?
Yeah.
It is. We can skip doing this one. Blow it off. And in fact, that's what the compiler does. It organizes the code in such a way that this half is not even checked. You get some speed increase out of that. If it's an AND, though, you have to rule this one out for short-circuiting. What do I mean by that? Let's change this to X is equal to 4. So, is X equal to 4? No, X is not equal to 4, so it doesn't even have to check the rest of it, right? So that's called short-circuiting. If the first half evaluates to true, and it is an OR, then the second half, the right-hand side, is skipped. That's called short-circuiting. Since X is 3, don't even need to know if Y is whatever, because the expression is already true. If the first half is false, and it is an AND, then it short circuits, then it skips the rest. X is not equal So why bother evaluating y? Does that matter most of the time? No. But you can have functions that return Boolean values. If door is open or trunk is open, ring buzzer, you know. Something dumb like that. These are functions. If this one is true, it's not going to call trunk is open. Yeah, 99.99% of the time that's fine. But if you program this expecting trunk is open to be called every single time door is open, and this is a bad example because I'm not coming up with a good one, then it's only going to call the first one sometimes, and other times it will call both of them, because if this evaluates to false, it has to check the second one before it knows whether the whole thing is true or not. Another example would be if you wrote it like this, and I strongly recommend you don't write things like this, but if plus plus x is equal to 3, or plus plus y is equal to 0, if, in fact, plus plus x is equal to 3, it's not going to add 1 to y.
Oh, okay.
And you may have thought that it would. So don't put plus pluses inside if statements anyways. That's just nasty.
It
But
does look disgusting.
you can. Yeah, so I'm going to erase that. That's
Well,
bad.
because when I looked at it, I didn't really know. It looked like you were like if, but then you were just doing 2 increments, but then you did it. So I say if if you add 1 to x and it equals 3, then
Right.
it's going to add.
Then it will add 1 to y and check to see if it equals 0.
Oh.
And you wouldn't. That's a bad way to do it. What I would do is x plus plus semicolon y plus plus semicolon, and then I would write my if statement. You know, if x is equal to 3 or y is equal to 0. That's a far better way to do it, because the side effect is that sometimes y would be incremented and sometimes y would not be.
It just looks confusing because you're not incrementing. You're not incrementing. Well, oh, you are incrementing both of them. Never mind.
We are, but only if
If
this one is
true.
true.
Okay.
No. We're only if this one evaluates to false, it has to come over here and check that one as well. That's the only time that one's incremented. That's why you never. I strongly recommend not I usually make the increments separate from the operation, and not everybody does that. Some people are happy doing things like that. C out x plus plus. Okay, great. Why not just C out x and then increment x plus plus? That's the simplest example. And it works to do it the other way, but if it gets to be more complex, then writing stuff that's easy to understand is at least as important as making, as anything else. Okay, so checking a range, we've already talked about this. If you're checking to see if something falls within a specific range, you want to use AND. If you want to check to see if something falls outside of a range, you use OR. Here's what you cannot do, and people try to write that because it works in algebra books, but it doesn't work here.
Oh, I've tried. Yeah.
Yeah, if 0 is less than grade is less than 100. No. That doesn't work in this language or in any other programming language I've seen. And it's perfectly reasonable to wish that it did. It just doesn't. Why is that? Because this one gets evaluated first. That one returns either a true or false. And then we're comparing true or false to being less than or equal to 100. And true is not less than 100, and neither is false. So it just does not parse. Menu-driven programs. Program execution controlled by user selecting from a list of actions. So you can have a list of choices on this screen.
Are switches better for
Yeah,
menus?
probably.
Okay.
So you might display a list of numbered solutions. Press 1 to open the door, press 2 to close the door, press 3 to, whatever. And then you test the user expression. If it's a match, then you execute the code for the action. If not, you go to the next expression. Okay, I'm going to go grab an assignment that we're going to do both as in-class and homework, so uno momento. Okay, so here's our assignment. We're going to do part of it in class, and then we're going to do part of it at home. So what this program is going to do, we prompt the user for the diameter of a sphere in feet, and then prompt for the material, either ice, aluminum, or gold. And if you've done this before in one of my other classes, sorry. Determine the density based on the material, and then calculate the volume of the sphere, and then calculate the mass. So, if you have a ball that big and it's made out of gold, it's going to be pretty heavy. If you have a ball that big and it's made out of ice, it's going to be a lot less heavy. So, we're going to ask for the size of it, we're going to ask for the material, and we're going to print how much that weighs. So here's our little table of stuff that we want to implement. Actually, we're going to only implement this. We could do this one too, but I just put this in here for fun. These are our sizes. A marble is about 0.05 feet. A golf ball is about 0.14 feet, and so on. We could ask them for an item, but I think it's easier just to ask them for the size, not restrict them to only these widths. Okay, so let's make a new project, not just a new file, but a new project. File, new project. And let's call this project sphere or homework. I think it's, what homework assignment are we on? I think so too. Nope, we're on 5. Okay, so if you want to call it homework 5, you can. Homework 5 space sphere. Create a CPP file. So add new item. You could leave it source.cpp, or you could call it sphere.cpp. I don't think we're going to need strings, but we certainly will need IO. So in # include IO stream using namespace std. And anytime I'm doing this, if you already have the boilerplate nearby, you may as well just grab it. Int main system. Did one of y'all warn me that I didn't have a return statement at the bottom of my main? I thought somebody did, and you were correct. I didn't.
Oh, what? I keep forgetting. I know. I'm trying to remember why you tell me to put the return. Because I thought they automatically return a value.
If it's a matter of C++ being a lot more loosey-goosey than other languages. In other languages, if you define a return type, you have to return a number of that value, like in Java. In C++, if it's main, it doesn't care if you return a value or not, which is weird. But if we renamed main to main2, then all of a sudden it starts carrying. And it's bizarre that if you have a function that's named one thing, it doesn't care if you return a value, but if you name it something else, it does care. So I'm going to try to always remember to add the return 0. Alrighty, so how do we want our program to look when it runs? Let's see if there's an example. No. What I really did is I gave you code to copy and paste, and I'm not doing that. We're going to create it together. I think we learn more by doing that. So we need a couple of variables. We need a variable for the width, the diameter, and we need a variable for the type of material. And then we will need a variable for the density of that material. So we need 3 variables. So I think type could be, yeah. Now I'm wishing I had included a string. So I'm going to go back up and add include string just for the menu to where we say ice is going to be 1, and gold is going to be 2, and so on. Okay, so let's ask them. we need a string, and we're going to call that material. And we need two other values, the diameter and the density and the mass. I said two. Mass is going to be what we calculate based on the other two. So let's ask the user what the ball is made out of. What is the sphere made of? And let's give them some choices. 3 choices listed here. Ice, aluminum, and gold. So C out A for ice, B for aluminum, that's kind of confusing, C for gold. And let's let them type it in. So CIN into the material string. Next, ask them for the diameter of it and store the input into a variable named diameter. And if you've already typed in everything I have up here, go ahead and add that. So C out, what is the diameter of the sphere? Slash in feet. So the equation for figuring out the mass, I'm just going to kind of blue sky this, I'm going to put in comments right here, is that the volume of a sphere is equal to pi times r squared. Now we don't have r, we have d, so we'll have to figure that. And then once you do that, then the mass is equal to volume times the density. So we don't have r for radius. We can calculate radius. We divide it by 2, right? So we know we need 2 more variables. We need one for radius
And volume.
and then one for volume. But we're not ready for that stuff yet because we don't know what the density is. And the density is going to be based on the material. So I'm going to kind of leave that double radius, double volume there, but instead I'm going to put up here, if the material is equal to A, that meant that the density is equal to, and I forget these numbers, 55, 168, 1200. So if material is equal to A, density is equal to 55. In this particular case, we could get away with forgetting the ifs, but, excuse me, the elses, except that I want a catch-all down at the bottom where it says invalid choice. And to do that, we would need to chain all of these with elses. So else, if material is equal to B, density is equal to, I believe, 160, yep. Else if parentheses, material is equal to C. Density is equal to 1203 pounds per square feet per cubic foot. So if you have a cubic foot of gold, it weighs 1,200 pounds. And think about that the next time you're imagining your D&D character finding a chest of gold. That gold would be really heavy.
Doesn't weigh your inventory.
I think we ought to put comments here. A is ice. B is aluminum, or if we were British, we would call it aluminium for some reason. And C is gold.
Yeah, they do it much. It does prove they're superior to us.
Yeah.
And make sure you change that. Density equals 168.
Oh, yeah. I put equal there. That's wrong. Now would be a good point to compile it. Compile it and run it just to make sure we don't have any syntax errors. So what is the sphere made of? It's made of ice. What is the diameter? 100? Great. Okay, it doesn't do anything, but we at least got through it without any syntax errors. There was one more else I wanted to put, though, which is if they made an invalid choice. So I'm going to tack on one final else, which is not else if, it's just else, and then C out invalid material. Here I actually need my braces in order to accomplish what I'm about to do. Because I want to either set the density to 0 or I want to return out of main entirely. So I'm going to need braces here so that I can chain on 2 commands in the block. Like that. You could put braces around all the others too. So after you add that, run it and choose something else other than A, B, or C. All right, guys, we've been here an hour and a half. I want to...
Or just make it lowercase.
Yeah, if you want to check for lowercase, you can make it if material equals quote A, L, or material equals lower a, or material equals quote ice. You know, you could do that. So I'm going to take a break, pause the recording. So this is what it would look like if we were implementing that same code as a switch statement. And switch statements and menus go hand in hand. So it just kind of depends on which syntax you like better. Do you like that? Or do you like if-elses? I have a preference for switch statements myself.
I just didn't understand it the first time I saw it, but now I get it.
Yeah. But like I said, I do not believe that this language supports switching on strings. We better figure that out really fast. So I'm going to throw a quick little test in here. Don't type this, but switch based on the material. Case A, colon. It's already starting to argue with me. It didn't like the fact that it was a string. So what we would need to do is pull the first character of the string out and store it in a character. So to get that code to work here, we would need to do this. Something like char type is equal to the first letter of the material string, like that. And then we could switch based on the type, like that. We'll do that when we implement the list of shapes, I mean the sizes. All right, let's go back in here and finish this. We've got the density now. we've got the diameter, we don't have the radius yet. So radius is equal to diameter divided by 2, and now we actually are modifying our code again. The volume is equal to 3.14159. I know that we can get pi out of the CMath library, but I'm just going to do that. If they want to know the weight of a snowball down to more than 5 decimal points, then they've got issues. Times radius, and then lastly, mass is equal to volume times density. And let's give them some feedback. See out the volume in cubic feet is followed by volume, followed by ENDL. And then see out the mass in pounds is followed by mass, followed by ENDL. So it's ice, it's got a foot diameter. Our ice ball weighs 43 pounds. Sounds good to me. I'm going to run it one more time. Same shape, foot diameter, but it's going to be made out of gold. It'll be much heavier. C for gold. It's 1 foot wide. It weighs almost 1,000 pounds. All right. Make sure everybody's got this part working before we go recklessly expanding. All right, so the last thing we're going to do to this program before we call it done is in this document here, it lists different sizes. A marble got a diameter of 0.05 feet. A golf ball's got 0.14 feet. A baseball's got that, and so on. So we're going to make another menu. This is kind of dumb. That lists all of those sizes. I guess we could even put one in that was other, you know, and then if they chose other, they could type it in directly. But let's just run with it. We're going to print off, we have 6 of these sizes: marble, golf ball, baseball, basketball, beach ball, and exercise. So we're going to have choices, you know. If we numbered them, we wouldn't have to do any conversions. 1, 2, 3, 4, 5, 6. We'll do that. Marble, golf ball, baseball, basketball, beach ball, exercise. All right. So up here where we say what is the diameter, let's comment those 2 lines out. We're not going to ask them the diameter anymore. We're going to prompt them for the type and then figure out the diameter based on the shape. So we need a new variable, which is going to be called shape, you know, some menu choice. I'm going to make it an int because you can use a switch statement on an int, unlike a string. So int, I'm going to call it shape. And we just need to offer these choices. See out what is the size of the sphere.
That if statement, that like all the stuff that we have for the diameter, or for the, oh wait, never mind. That's for material. Sorry, never mind.
Either one's going to work. Because they're all the same shape. They're just different sizes of the same shape. Why is it? Oh, I put the semicolon in the wrong, inside the string. Okay. Semicolon goes outside the string, Jeff. Let's now come up with our little table. Cout 1 equals marble. /n and I'm just going to copy that and paste it so that I can put in 6 different choices. So 1 marble, 2 is golf ball, 3 is baseball, 4 basketball. Should have also put BB in here. Beach ball. And exercise ball. Yoga ball, whatever they're called.
Medicine ball.
Medicine ball, thank you. I like that better. Medicine ball. And obviously it should say 2 is equal to golf ball, 3 is baseball, 4 is basketball, 5 is beach ball, 6 medicine ball. Now we're going to write a switch statement based, well, we need to read in their input. So CIN into the shape variable, CIN greater shape. And then switch based on that shape variable. And we're going to have 6 different cases. Case 1, I certainly do not have these sizes memorized, so I'm going to have to dock this on the side again. So case 1, diameter equals 0.05 break. Now why are these breaks here? Why do we have to keep putting breaks in here? That's kind of annoying. Well, we'll talk about that in a minute. Case 2, diameter is equal to 0.14 break. Case 3, diameter, and could we have found a better way to do this? Probably so. We could have stored all of these diameters in an array. And so if they chose 2, you know, we just used element number 2 of the array. And if they chose 3, that would have been a lot better than using a case statement for this. But didn't think of that. And this chapter is not about arrays. I thought we were going to get done with this chapter and hit arrays. But anyways, so if it's 4, it's got a diameter of 0.80 break. If it's 5, diameter is equal to 1.67 break. And if it's a 6, diameter is equal to 2.50 break. Y'all saw me if you were watching when I was typing in the notes, I was putting the break on the same line. And now that you're looking at it here, you probably see why. Just because it padded it out considerably. You know, these 6 choices filled up my screen. Not a problem for y'all. It's a problem when I'm trying to, you know, keep everything on the screen at one time so that it's not, you know, so you can type along. If we left a break out, it would do fall through. So like if I didn't have these breaks here, I deleted them all, then if they typed 1, it would set diameter equal to 0.5. and then it would set diameter equal to 0.14, and then it would set it to 0.24, you know. That's called fall through. So you don't want to leave the break statements out except in very, very rare circumstances, and if you really do want fall through to occur, it'd be a good idea to have the word break there, to comment it out, and to add a comment as to why you want fall through to work. You want to make it that clear, because I guarantee some do-gooder will come behind you if you're working in a team and fix it. They'll add breaks, you know, where there weren't supposed to be any, thinking that you were an idiot. So you need to convince them you weren't an idiot in your comments. All right, it's possible this is actually going to work. If I need to scroll back up to one or the other part of the code, let me know, but I also want to test this out really, really fast. Okay, it's an ice, it's a baseball, weighs 2 pounds. So if somebody's making a snowball out of solid ice and they throw it at you, it's going to hurt. How much is a golf ball of ice weigh? Less than a pound. Still kind of heavy. So golf ball sized hail is almost a pound per piece. How about a basketball made of aluminum? 84 pounds.
You ain't shooting
You
that
just
at
killed
all.
somebody by throwing that at them.
Yeah, yep.
You don't even get down.
And a basketball made of gold, 600 pounds.
Somebody's dead.
Yeah, you're not going to be able to lift that unless you're a lot more awesome than I am.
Oh no, I can just imagine somebody throwing that off the Empire State Building.
Right.
Somebody died,
Yeah,
and there's a whole other thing there.
yeah. You know, the legend is if you throw a penny off, it kills someone. I don't know if Mythbusters ever did anything.
I don't. Oh, no, seeing it's made out of. Okay.
So the only other thing I could think that would make this cool, besides what I want you to do to it, is offer choice 7, which is other. And if they choose other, we just ask them for it. But really, you've already gotten the point. You've seen the difference between if statements and the switch statement. Why do I consider switch statements better? I think they make the code look more structured. That's the real reason why. You know, conceptually it's the same code. We forgot to put a default in there, though, to yell at them. So let's throw one more case in here. Default, colon, and let's tell them invalid choice. And let's tell them assuming diameter of 1 foot, and then set the diameter equal to 1. Yeah, we could crash the program. I mean, no, we could use a return statement to bail out instead, but why didn't we do that with the density? Because I think, I don't know. Can't think of a good argument for having. What's the right way to do these kind of things is to present them with a menu, but if they choose an invalid choice, just keep continuing until they finally choose a good one. Yeah, that's the best way to do input. And if we put these things inside of functions, that'd be a nice thing to do. You know, get material. You know, you call get material, it offers that menu, and it returns the density. That might be even kind of fun to do right now since we had that, that video on functions. Let's see how much more there is in the PowerPoint, though. Validating user input. Users are dumb. Users are evil. They will try to crash your program. Inspecting input data to determine whether it is acceptable. And I'm kidding. They're not dumb and they're not evil. It's just that if people can find a way to break their program, your program, they will. It's kind of like Murphy's Law. Bad output will be produced from bad input. Like the old saying, garbage in, garbage out. So you can do tests on your input. You can make sure that your input is within a specific range. You can check to see if it's reasonable. If you're writing a program You know, it's an iPad application for nurses to use to take people's temperatures, and they enter a temperature, you know, of below 0. The patient probably does not have a temperature of below 0 or greater than 200 degrees. So you could check the range, you could check the reasonableness, you could check to see if it's a valid menu choice. You can make sure that it's not going to divide by 0 and crash your program. Here they do some input validation. You know, if you enter something invalid, it asks for a test score. Enter a test score, and if the grade is greater than 100 or less than 0, then they say that that is an invalid score. Run it again and get it right. Okay. Comparing characters and strings. If you're comparing two strings with an if statement, like this, go back to our notes. If A is less than B. If A and B are strings, they're compared alphabetically. But there are quirks because it's really done by ASCII values. So Abe is less than Bob. I'm going to type all caps first. Abe is indeed less than Bob. Mary is indeed greater than Jill. Not kill. Violent today. And so on. But since it's ASCII, lowercase and uppercase mean different things. And on the ASCII chart, lowercase letters are greater than uppercase. So Abe is not less than Bob. Yeah, it is. So so Abe is less than Bob, but if you did them in lowercase, lowercase Abe is not less than uppercase Bob. Uppercase letters register as being smaller numbers than lowercase letters. And the reason why is the ASCII chart. We did the ASCII lecture, did we not? Say no if I didn't.
On ASCII?
Yeah.
Yes, you showed us how to.
Pulling up an ASCII chart and looking at that. Does that sound familiar?
A is what, 75?
And you've taken my other classes where I've done it 2 times. I want to make sure y'all three know what ASCII is? Have we done a lecture on ASCII? Am I seeing an
No, you did it in here.
Yes or no?
Refresh.
I don't know.
You don't remember? Okay, fine. So an ASCII chart, every letter you type into the computer has to be stored as a number. The number is determined by these charts that were created in the 60s, this coding standard.
Oh yeah, I remember.
I did that? Okay,
Yeah,
okay,
I
okay.
think you did this on the first day.
Okay,
No,
right.
I won the first day. I think it was like maybe third.
Maybe second day or something. Anyways,
Yeah.
so it's been a while. So anyways, the way these work is a B is greater than an A. So, you know, and a D is greater than an A. So your disturbed songs will be lower in the list, you know, than your ABBA songs. You know, so it'll sort them alphabetically. But the lowercase ones are all in a different series, you know. So lowercase a is greater than uppercase A. Lowercase b is greater than uppercase b if it's doing strict comparisons by ASCII order. So sorting algorithms have to be a little bit wiser than that. One thing you can do is just convert everything to uppercase before you start comparing them. And the conditional operator. Have we done the question mark?
Yeah, you put it there when you don't want to sign it up. Wait, no, that's not.
Well, we'll hit it again because it doesn't take much time to lecture about it. If you have something like this, temperature is equal to 72. If temperature is less than 32, state is equal to ice, else state is equal to not ice. Whatever, you know. You could write this like this. State is equal to, is temperature less than 32? If it is, then the state is equal to ice. Else the state is equal to not ice. That's called the ternary operator. And I do think I talked about that. So A is equal to 100. B is equal to, and you don't have to put the parentheses here. I just put that there to make things easier to read. Okay, so if you look at this, what does B equal after these statements run? I'm going to go ahead and put the parentheses in now to make them easier to read, but they're not strictly necessary.
B equals yes, I think.
Okay, so is this first part true or not? Is A equal to 100?
Yes.
Yes. A is equal to 100, so B is equal to yes. So is A less than 100? That's a false because 100 is not less than 100. So it's going to be equal to the second thing. So C is equal to goodbye.
Yes, goodbye.
And what about the third one? Is A greater than 50?
Yes.
Yeah, so D is equal to Bob and not Mary. Now, Java, for you Java students, supports the conditional operator as well, but C++ goes one further and lets you embed function calls inside it.
Yeah,
I guess Java could as well, but you could do things like this. If you wanted to, you could write this. A greater than 50, call Nito, else call Drats, you know, like that. And to me, that's kind of nasty, but to other C++ programmers, they may think that that's awesome. What it means is if this is true, then it's going to call Nito. If this is not true, it's going to call Drats. And they probably given an example of that. Or you could do something like this. And this absolutely would not work in Java. I believe that that would still, perhaps. But if you did this, A is less than 32, question mark, then B is equal to 20, colon, C is equal to 30. You could do that in this language. And it's not too hard to read, but it's kind of perverse, in my opinion. For this, though, I think this is a real clear syntax, easy to understand. If you're using it for things like that, yeah, it's part of the language, but it's not not compatible with other languages that also support the conditional operator like Java. I'm real sure that would give you a syntax error in Java. So here's the expression. Look what they're doing. They're showing you what I just told you not to do. If this is true, then set y is equal to 10. Else, set z is equal to 20. All right. Switch statement. We know what a switch statement is. Switch based on an expression. The expression has to be something that can evaluate to an integer, which is either an int or a char.
What's mean
Next lecture.
Okay. No, because I
An
don't
enum is when you give a series of values and then they are assigned integer equivalents. But we will hit that in another lecture.
kind of like a dictionary or something.
Yeah, yeah. So the break statement exits a switch statement. If you leave it out, the processing falls through to the next switch. Here they used it to their advantage. Our TVs come in 3 models. They have 3 models, the 100, the 200, and 300. Which do you want? If it's a 300, it comes with both picture-in-picture, stereo sound, and remote control. The way they get away with doing that is they didn't put break statements. If it's the model 200, it doesn't have picture-in-picture, but it would print out stereo sound and remote control. And if it's a 100, it only prints remote control.
That's all. Okay, that's smart.
Yeah,
You can only choose the 100.
yeah. Switch statement is a natural choice for menu-driven programs. We've seen that. More about blocks and scopes. So this is going to be the last thing we lecture about. The scope of a variable, and we've talked about this before, is the block in which it is defined, from the point of definition to the end of the block. Usually people define their variables at the beginning of the function, but you can define the variable close to use. So on the code that we wrote today, we had some variables defined up here, but later on we had another one there, and then we had some more variables defined down here. Absolutely would not have been wrong to move all of those up to the top. Just depends on whatever you think is easier to read. I kind of like putting these here because these variables don't take effect until down here, right? I mean, this is the calculation stuff, so why not define the variables as close to the calculations as possible? That's my opinion. Other people would argue that you would put them up there at the beginning. And if you've taken a C class, then you probably absolutely have been declaring your variables up at the top, because I do not believe that you can declare them on the fly unless the C language has incorporated that change. So the block of the scope of a variable, if you define a variable here like this, I'm going to make a variable called int x. I could not print that out here. And I know I've already done this lecture, so I'm not going to talk too long about it. Why is x not available here?
Out of scope.
It's out of scope, meaning was defined within these 2 braces. We are no longer within those 2 braces. If you want a variable to be accessible anywhere in your chunk of code, you make it a global variable by scrolling up to the top and putting it in front of main. So I could do int x there, and then it would be available anywhere, even in other functions in the same CPP file. If you're going to do that, you should stick it in a namespace. So variables defined within braces are called local. They have local or block scope. If you define one variable and then later on in a nested loop or something you define it again, the outer definition of it is not available. Masking, hiding it, so that's not a good idea. They may give an example of that, I don't care. All right. So I think we're done for today. The assignment to finish this is, well, the homework is to finish the program we just wrote. I will upload this, and what it is it comes with extra materials to implement. So is it going to take very long to implement? No. But instead of just offering ice, aluminum, or gold, you're going to add iron, cedar, soil, paper, and osmium. By osmium, it just happens to be the heaviest naturally occurring metal. It's heavier than gold. Gold weighs 1,200 pounds per foot. Osmium weighs 1,400 pounds per foot.
That's crazy.
If you feel like expanding this with a whole bunch of other ones, like uranium and whatever, yeah, more power to you. But I at least wanted to support those materials. So I will upload that. Since we have a whole 15 more minutes, I believe, or so, why don't we go ahead and put one of these things into a function? How about this one, the shape? What I want you to do is to grab everything from int shape all the way down to that default right there. Cut it and replace it with the line. Make sure you cut it and not just delete. Diameter equals get diam. Something like that. Now it's going to underline that as being an error because we don't have a get diam function defined yet. We're going to do that. Scroll up above main. On second thought, let's put it down at the bottom. But we're going to have to add a prototype. So after you add this line, diameter is equal to get diam, go to the very bottom of your code, and we need to define a function. The way you define a function is you give it a type, and then you give it a name, and then inside parentheses, you define any parameters it accepts. This one doesn't accept any parameters, so we're not going to put anything between the parentheses. Then paste that code that we just copied. It's going to complain that it doesn't know what diameter is, so we need to come up here and also define diameter right here.
I cut it out, and now it's saying that all my COUts are ambiguous.
And
I don't know.
okay, so paste all of that stuff that we did, but above it add the line double diameter, and then below it, the very last statement of code should be return diameter. So I'm going to come down here, and before my very final brace, I'm going to do return diameter. Now when I try to build it, it's not going to build. I should get an error. The error I get is get diam, identifier not found. In some languages, you would not have to worry about this. Java doesn't care the order in which you define your functions. C and C++ require, and Python, require you to predefine your functions. The order is very important. If I had defined this get diam above main, it would be all right. But I defined it below main, so the call to get diam right there, the compiler needs to know not only the name of the function, but what it returns and what parameters it accepts, or else it won't be able to compile it. So we need to add what's known as a prototype. A prototype is your function header, but with no body, so you just end it with a semicolon. So we're going to go above main, right here. We're going to define our get diam as being a double, so double space get diam, parentheses in parentheses, semicolon. This is our prototype. I'm going to give it a comment to that effect. Prototype our function. A prototype is used by the compiler so that it knows what the name of the function is, what parameters it accepts, and what it returns. Now that we have a prototype for it, we could move that function into an entirely separate file. And as long as the linker could find it and link it in, it would still work. So typically you stick your prototypes in header files, and then you stick your code in CPP files, and you can break them up that way. All right, I didn't break mine. Let's make a Dropbox for this. So for in class, F is the first version of the sphere program. What we did today. And then as 5, that's our BMR assignment. Excuse me. 5 is the homework version of it. So go ahead and put your CPP for what you've done so far, and then I'm going to wander around and make sure that I didn't break your code with the change we just made. Did your C outs finally start working again?
Yeah.
Okay.
But, now everything else.
Okay, just a sec. So we had 2 folders today. Ands, ors, and nots. That was the Word document. I see 2 submissions. Please, everybody else, go ahead and upload your Word doc. I know everybody did it. And then also the CPP that we just did today. Some of y'all are so fast, you get the program uploaded before I assign a due date. Alright, I don't know why I gave the file the name homework assignment 5 sphere assignment sphere, but you'll figure it out.